Hello everyone. So in this video, we are going to discuss question number 48 of GATE DA25 exam. Okay, simple question, but it was asked for 2 marks here. Okay, and this question looks like a question from a calculus, a subject, but it is related to a machine learning topic as well. Okay, so let's read the question. Which of the following statement is are correct about the rectified linear unit activation function defined as ReLU of x equals to max of x comma 0 where x belong to real numbers. So we have discussed this particular function in neural network topic in machine learning, right? So we have discussed various activation function and one of those was rectified ReLU function here. So you can see this function rectified ReLU function equals to maximum of x comma 0. So this is basically used as an activation function for a neural network here. But this question is based on a simple calculus topic as well because we need to check whether it's continuous or differentiable or not. Okay. So if I draw a graph for this particular function, so here we have a y, here we have x, and let's say for example this is y, right? So maximum of x comma 0. So and x belongs to all the real numbers. So if I put a number less than 0 here, let's say for example minus 1, minus 2, in that case maximum will be 0 only, right? So it will be like this. So for all the negative numbers, it will be a 0 only like this, okay? And if we put x equals to 1, 2, 3 like that, then maximum will be 1, 2, 3 like that only. So what it is doing, it is giving us the linear output. If the input is 1, then the output is also 1. If the input is 5, then the output is also 5 like that. So it will work in this particular manner. So you can see this particular graph for rectified ReLU function here. Because whenever the value of x is less than a 0, so that will be 0 here, greater than a 0 will be equal to that particular number x here, right? So this is what rectified ReLU function is. Now what about the option number A here? Is continuous everywhere? So by looking at this particular graph, we can say yes, this is basically continuous everywhere. Even at x equals to 0, if I calculate left hand limit and right hand limit, it will give us 0 only. So we can say yes, both limit exist and it is equal. So our function is continuous everywhere. So option A is correct here. What about option number B? Is it differentiable everywhere? So we can see here it is differentiable at in the positive x-axis, even the negative x-axis as well. But what about at point x equals to 0? At x equals to 0, right? If I go from the left side here, you can see from a left side, the derivative will be what? A 0. But if I go from the right side here, derivative will be what? 1 here, right? So we can say it is not differentiable at x equals to 0. It is continuous. The function is continuous at x equals to 0, but not differentiable. Very, very important point. So this function is continuous everywhere, but not differentiable at x equals to 0 here. So option B is not correct everywhere, right? What about option number C? Is not differentiable at x equals to 0? Yes, this is what we have discussed. So option C is correct. Now what about the option number D here? Rectified ReLU x equals to rectified ReLU of ax for all the value of a belong to R? No, right? So if I say rectified ReLU of 3, right? So that will be what? A 3 here in the output. If I say rectified ReLU of 3 into x, so whether we will get the same output here? No. Also, even if I say a is negative, because a have mentioned a belongs to all real numbers, right? So if I say rectified ReLU, 3 will be, this answer will be 3. But if I use this ax and here a is minus 2 into 3, that will be minus 6. Again, maximum of minus 6 comma 0 will be what? 0 here. So again, this will be not equal, right? So option D is not correct. So only option A and C are correct here. Simple question for 2 marks, nothing in that. Even if you don't know about this particular rectified ReLU function, still you can answer this question based on the calculus concept of continuous and differentiability. Okay. So that's it. But please remember, this particular function is very, very important from neural network point of view. Okay. So neural network point of view. So that's why we have put this question as a part of machine learning as well as calculus subject. Okay. So this question can be part of both subject as well. Okay. So that's it from my side. I hope you understand the video solution of this particular question. Thank you.